film badges, and that film is exposed by the energy from the radiation, it gets a bright spot. We can figure out how much and whether or not that particular person has been exposed to too much.
That's a cheap way.
Yeah, it's the easiest way. Probably. Alrighty, which kind of answers number 31? How do radioactive nuclides affect photographic film?
Skip the.
I did not.
No, you
Did
didn't.
I?
No, you didn't. No, it.
Chris has his pants on fire.
Yeah, pants on fire, big time.
Oh, did you see that one progressive commercial where like the guy's pants catch on fire?
I don't know, did I? I don't think so.
Your pants are
They
on
lie about
fire.
their company and then their pants
Really? And their pants catch on fire.
It's amazing.
See, it does happen. Yes.
What was 28?
What was 28? Is that the one? Oh, how do they compare? REM depends on the Röntgen. They're related. It's the like effect on man. All right. So back to 30. No.
Yeah.
31. How do radioactive nuclides affect?
Wait, no, it's 30.
Oh, I did that.
No, we did it with.
Oh, how each device. You're right. I skipped that one.
Oh.
Okay.
Yeah.
Well, they're so close. Well, I mean, I've answered it here. Geiger counters measure electrical impulses from the effects of ionizing radiation on the gas. Okay, how about we stop with the sign language? Thank you. Scintillation counters measure the electrical impulses from flashes of light. And film badges are actual photographic film that gets exposed, gets a bright spot as the energy hits it. Yeah, don't give me a dinosaur. They were not paying attention. Let's see. Now can we do number 31? How radioactive nuclides, oh, I said that, affects photofilm. 32, how radioactive substances can be used to date things.
How much of the stuff is left and then you find the half-life?
Right, so we need to know the half-life of the substance. We typically use what isotope for radiocarbon dating?
Yeah, carbon 12.
Carbon
14.
14.
C14.
C14. Carbon 12, not radioactive, but we do the ratio. Alrighty. 33. What radioactive tracers and fertilizer measure? Well, there's some radioactive isotopes and some fertilizers.
Phosphorus.
And where does the fertilizer go in the plant?
In the ground.
It's turds.
Okay, if the plant is living and absorbing nutrients,
Tough question. No lysosomes.
the radioactive things should go where?
Into the plant.
Up into the plant, right?
The core plant.
So if we put a radioactive tracer in there, we can tell how well the plant is absorbing these nutrients, the stuff that we're putting on, and is it, growing well because of it.
So what's it measure?
How well plants absorb.
Yeah, the uptake of the fertilizer by the plant.
Wait, what is it measured?
The uptake of the fertilizer by the plant, if it's absorbing nutrients or not.
No, the fertilizer's working.
Yeah, if the fertilizer's working. Thank you. That's a way to bring that down to the key point. What happens during fission? This is going to be one of those, which of the following does not describe fission?
Atoms split.
Atoms, larger, unstable nuclei split into smaller, more stable nuclei and release a lot of energy. Generally, that happens because of something like slow neutron bombardment. What is it about fission that leads to the chain reaction? So we'll kind of merge the next one in as well, 35. What happens in fission that then ends up causing a chain
It
reaction?
shoots off a neutron.
Shoots off one or several neutrons, and those neutrons do what?
Cause another fission reaction
How?
by shooting a neutron into the nucleus.
Okay, so they hit another nucleus. Do you have anything to add to that? Or did you have a question?
I was going to say, neutron hitting the positron nucleus, and then another negative.
Right. Yes. And then, but the key is the neutron. So the neutron being spit out by one nucleus is going to be hit another one, and so on and so on and so on. That's the demo with the ping pong balls and
That was a
matches.
good one.
Yeah, Ping pong.
We should try to.
Is it always gonna be neutrons or can it be other particles?
That's a good question, I don't know. Typically it's neutrons. Because we're getting rid of some of that mass and energy, and the neutrons are the particles that are kind of expendable, so to speak. I mean, that's not completely right. Alrighty, the next question has pictures for answer choices. Stop playing on your calculator. The next question has pictures for answer choices. And so you will have to find the picture of either the fission or the fusion reaction. If it's a fission reaction, it's going to start with some small particle and some great big particle and break into kind of medium-sized things. If it's a fusion reaction, it's going to start with two small little nuclei, have them coming together to make a bigger one. Okay? And then there will be some other things that are just chemical reactions that make no sense whatsoever in this particular problem. Okay. Now, this is going to be tricky to answer, not because of the difficulty of the problem, but because of the arrangement of the answer choices. And you would have pictures A, B, C, and D, and answer choices A, B, C, D. But it might be arranged like this. So you might know exactly the correct picture, but get the answer wrong. So here's letter A, B, C, D, and those. You're going to pick from one of these as your answer. And maybe this is D, and this is C, and this is A, and this is B. See how that gets messed up?
Yes.
So you might know that it's picture D. Don't write down D. Write down answer choice A. Because answer choice A is saying picture D. See what I'm saying there? Some of you will get tripped up on that problem for unnecessary reasons.
Why would we just make A